Hey everyone, today I wanted to talk a little bit about isotopes and isotope symbols, but I really want to focus on how we use isotopes and isotope symbols and also how we convey information about them. So, the first thing that we got to talk about if we're going to talk about this topic is what are called mass numbers. Now, we talked about this in class. Mass numbers are unique to individual isotopes of an atom. This is different from the mass that's listed on the periodic table because it's specific to one particle. Okay? So the mass number is always going to be equal to the number of protons and the number of neutrons added together. So for instance, right, like let's say you had a carbon atom that had 6 protons and 6 neutrons, its mass number would be 12. Now, we can use the mass number to convey a whole lot of information about particular isotopes. And one of the ways we do that is through what's called an isotope name or an isotopic name. An isotope name is just kind of a quick way to convey to one person or another what isotope you're talking about. So the way it's written is you take the name of the atom and then you add a dash at the end and then you include its mass number. So for instance, if you have an atom of uranium and you're talking about an atom of uranium that has a mass number of 235, we would call this uranium dash 235. So in conversation, it would just be uranium 235. Now, in addition to an isotope name, we also have what's called an isotope symbol. And this is a way to write this down and use it when you're talking about like a chemical equation or something along those lines. So the way that it works is it's similar to an atomic symbol. Here in my example right here, I'm talking about oxygen. You can see the oxygen in the isotope symbol has the atomic symbol right there. Okay, so the atomic symbol for oxygen is O, but in addition to the atomic symbol, we have a couple other pieces of information right here and right here. So in kind of the bottom left-hand position of the atomic symbol, we have an 8. And this 8 is the atomic number. The atomic number is the number of protons that you can find in this particular isotope. Now, the atomic number should match what's on the periodic table for oxygen. So if we were to look on the periodic table for oxygen, we would find that the atomic number is in fact 8. Now, in addition to this, there's also another number right up here. And this number is the mass number. Remember, the mass number is the number of protons and the number of neutrons added together. Now, if we use a little bit of logic here, right? If we know that the mass number is equal to the number of protons plus the number of neutrons, we can use this information to figure out how many neutrons there are in this particular isotope. Because I have my mass number, that's 17, and I have the number of protons, that's 8, right? That's the atomic number. So I know that the number of neutrons is whatever number goes right here. So rearranging this a little bit, right? 8 plus the number of neutrons is equal to 17. That means the number of neutrons is equal to 9. There are 9 neutrons in this particular isotope. Now, let's practice a little bit. What I want to do is I want to use just a little bit of information that we know about like a particular isotope to try and get all of this other information. So the goal is to complete this table with the isotope name, the isotope symbol, the atomic number, mass number, number of protons, number of electrons, and the number of neutrons. So let's start on the first one. On the first one, we only have magnesium 24. And this is actually a really good example because it turns out you can fill out this entire table with just the name. So let's start with what we know. The name is the name of the element with a dash and then the mass number. So I know my mass number is 24. Now additionally, if I look at the periodic table and I find magnesium, magnesium is right here. And when I look at the periodic table, the smaller number of the two numbers, that is my atomic number. Okay? Remember, atomic numbers are always the smaller of the two numbers you find in the box. And the other thing is the atomic number is always a whole number. There's no decimal atomic numbers. So for magnesium, my atomic number is 12. And that gives me a lot of information because I know the atomic number is the number of protons. But there's actually another piece of information because it says right here, I'm looking for the number of electrons in a neutral atom. And neutral is kind of a key word here, right? Because neutral means it has no charge overall, okay? So, logically speaking, if protons have a +1 charge and electrons have a -1 charge, in order for the entire thing to be neutral, you have to have the same number of protons and electrons. Let me try and diagram that out for you a little bit really quick. Okay, so in my magnesium, I have 12 protons, right? I'm going to just write +12, okay? Because each proton is a +1 charge, and there's 12 of them, so it's +12, okay? Now, I know my overall charge has to be 0 because it's got to be neutral. So, if I have +12 and I want to get to 0, the only way to do that is to have the same number of minus charges, right? So if I have 12 minus charges, then I have +12 minus 12. Those cancel out, and what I'm left with is 0. So in a neutral atom, the number of electrons has to be equal to the number of protons. Now we're going to talk about this later, but this only applies to neutral atoms, okay? And that's an important caveat, okay? I've got 2 boxes left to fill. I need the number of neutrons, but I know that my mass number is equal to the number of protons plus the number of neutrons. So if my mass number is 24, and of that 24, 12 of those are protons, 24 minus 12, I have 12 neutrons. Last thing, I gotta write my isotope symbol. Again, as a reminder, the isotope symbol is this guy right here, okay? So, first thing I'm gonna do, I'm gonna write the atomic symbol for magnesium, that's Mg. Now to fit it in the box, I'm going to shift it a little bit to the right of center because I want to put numbers to the left, okay? On the top left, I put my mass number, that's 24. And on the bottom left, I put the atomic number, that's 12. And would you look at that? I've completed this row just from the name, just from the isotope name. Let's work on the next one. The next one, I only have the atomic number and the mass number. So let's try and solve this out. Let's go with what we know right away. Atomic number is 82. That means I've got 82 protons. Because this is a neutral atom, I also have to have 82 electrons. My number of neutrons, that's my mass number minus my number of protons. So let's do some quick math. 206 minus 82. 4, 20 minus 8, that's 12. 124 neutrons. Okay, I know that atoms are identified by their number of protons. So if I go to my periodic table and I find number 82, that's this guy right here. That's lead. And lead's atomic symbol is Pb. So my isotope symbol is Pb. On the top left, I put the mass number, that's 206. Bottom left, I put the atomic number, that's 82. And there's my isotope symbol. Last, I need to write the name. The name of my element is lead. Then I put a dash, and then I put my mass number, 206. So my isotope name is lead-206. Hopefully this answers any questions you've got about how this process works. And if you need any help, come see me anytime.